up until this point, we have solved linear equations by using elimination, by using substitution. We then went and learned to solve a system of equations by Cramer's rule. What was Cramer's rule using? Not matrices now. Well, what about the matrices? It's the determinant. So Cramer's uses determinants. Today, I'm going to show you how to solve a system of equation using matrices, not determinants of the matrices itself. So let's say I have a system of equations and I have a1x plus b1y equals c1, and I have a2x plus b2y equals c2. I can represent this system of equations using matrices. So let's say I said matrix A is the coefficient matrix. So it's A1, B1, A2, B2. I say matrix B is the variable matrix, XY. And I say matrix C is the constant matrix, C1, C2. Now I can do matrix A times matrix B equals C to get the system back to how it originally looked. What does that look like? So that would look like A1, B1, A2, B2. Let's just do matrix A times matrix B first, and then multiply that by XY. So I have a 2 by 2 and a 2 by 1. Is this in a good format to multiply a 2 by 2 times a 2 by 1? Absolutely. And what is our solution matrix going to be? 2 by 1. All right, so now let's multiply. So I'm going to multiply my first row times that first column. So I'll have a1x plus b1y. And then we're going to multiply our second row by our column. So that's a2x plus b2y. And isn't that what we had originally got at a1x plus b1y and then a2x plus b2y? And then that would equal c1, c2. So c1 would go with the first row, c2 would go with the second row. So that's how we take a system of equations and put them into matrices without actually changing the value of the system of equations. So I needed to show you that. Now let's look at this. So we're going to have matrix A times matrix B equals matrix C. And now, do we agree we would need to solve for the variable matrix? So I'd need to solve for matrix B. Now, to solve for matrix B, I would need to isolate, think back to algebra 1. We need to isolate B, get it all by itself. But now, in order to get B by itself, I need to get rid of A. Normally, since it's being multiplied, we would just divide. But have I showed you how to divide matrices? No, because we don't divide matrices. So now I need another way to eliminate matrix A, or at least not get it to be 0. I need it to be 1. What can I multiply matrix A by to get it to be 1? You got it, the inverse of matrix A. So if I multiply the left side by the inverse of matrix A, what do I have to multiply the right side by to keep it balanced? The inverse of matrix A. So we're going to end up with B is equal to the inverse of matrix A times C. And that is how we're going to solve a system of equations using matrices. So the first thing I'm going to do is show you how to solve a system of equations using matrices by hand. I will only ever ask you to solve a 2 by 2 by hand. Anything bigger than that, we're going to use the calculator in Desmos. So let's go here. We're going to solve using matrices. I'm going to have negative 2x plus 8 equals negative 3y, and then x plus 2y equals negative 3. So we're solving using matrices. What does Cramer's use? Determinants, exactly. So now when we're solving using matrices, just like when we solve using determinants, we want to put it in that elimination format where the variables are on one side, constants are on the other side. So I'm going to keep the negative 2x. I'm going to move the 3y over and move the 8 over. So I'll have negative 2x plus 3y equals negative 8. And then the bottom equation is set up perfectly for us. X plus 2y equals negative 3. Now, the first matrix, which I'm going to call A, is going to be the coefficient matrix. So it's negative 2, 3, 1, and 2. Matrix B is going to be our variable matrix, X, Y. And our matrix C will be our constant matrix, which is negative 8, negative 3. Now, to solve this using matrices, I need to solve for B, and B is going to equal the inverse of matrix A times C. Now, we learned last class the order you multiply matters. Remember that? So when we're multiplying, that inverse has to come first. So it's always the inverse times the matrix C. So let's put a little note there. Inverse must be first. Order does matter. Okay, well, we know matrix B is XY. I need to find the inverse of matrix A, and I know matrix C is negative 8, negative 3. So what I'm going to do now is over on the side of my paper, I'm going to find the inverse of matrix A. And if you guys remember, by hand, to find the inverse of a matrix, we're going to do 1 over the determinant of the original matrix times, we're going to switch spots A and D and negate spots B and C. You guys remember that from last class? Okay, so now I need to find the determinant of A. Well, the determinant of matrix A, do you remember, you guys, we multiply on a diagonal and subtract? So it's going to be negative 4 minus 3. So the determinant of matrix A will be negative 7. So the inverse of matrix A will be negative 1 over 7 times, I'm going to switch spots 1 and 4. So 2 and negative 2 get switched. And I'm going to negate spots 2 and 3. So negative 3 and negative 1. Is anybody confused with how I got this set up for the inverse of matrix A? All right, now when I have a scalar and then a matrix, what do I have to do with that scalar? Distribute it in. So the inverse of matrix A is going to be negative 2/7, positive 3/7, positive 1/7, and positive 2/7. And now I got my inverse. So I'm going to have XY is equal to the matrix of the inverse of A, which is negative 2/7, 3/7, 1/7, and 2/7 times matrix C, which is negative 8, negative 3. And guess what we have to do now? Multiply. So I have a 2 by 2, and this is a 2 by 1. Is this in a good format to multiply? Yes. What will my solution be? You got it. So now let's multiply. First row by first column. Negative 2/7 times a negative 8/7 is a 16/7. 3/7 times a negative 3/7 is a negative 9/7. 16/7 minus 9/7 is 7/7, which is 1. I'll write that in a minute. Now I do the second row by the first column. 1/7 times a negative 8/7. 1/7 times a negative 8 is a negative 8/7. 2/7 times a negative 3/7 is a negative 6/7. So now if I simplify this, I get 1 and negative 2. You can leave the solution just like this in matrices, or you can say 1 comma negative 2, or you can say x equals 1, y equals negative 2. Do I care which way you write this? I do not care. Okay, so now what I'm going to do is I'm going to show you how to do everything we've done so far in Desmos. I'm going to teach you how to multiply matrices in Desmos. I'm going to show you how to add matrices in Desmos. I'm going to show you how to find determinants in Desmos. I'm going to show you how to find the inverse and solve a system of equations in Desmos. We ready? Let's do this. Oh, what time? When is it over? 51? 33. Oh, 33. We're good. Why are you making me scared? Oh, okay. So let's go to Desmos. And we're going to go to the matrix calculator right here. So you go to Math Tools, Matrix Calculator. All right, now the first thing I'm going to show you is how to enter a matrix into your calculator. Super simple. All you're going to do is type new matrix, and then we're going to adjust it. Let's say we want this to be a 3x2. So we make that, we just put a plus sign for that. Let's say we wanted a 3x4, you just add columns there. And all you're going to do, let's go back to a 2x2. And then all you do is literally type in the numbers inside Desmos. So that's a 1. Let's say I want this to be -1. Put a -1 there. Let's say 3. Let's say 4. Yes. All I pressed was new matrix. Did you guys go to the matrix to calculator? That was the first thing I said, kids. I said, go to the matrix calculator. Keep up with us. All right, now to save this in Desmos memory, we're going to press enter. To save this into Desmos memory, we're going to press enter. Okay, now let's say I want to find the determinant of this matrix. Right, so I'm going to enter that matrix in, press enter. So now matrix A is saved in Desmos memory. Do you guys see where it says DET? You're going to now click DET. And then it's saying, okay, well, find the determinant of what? So then you see all these capital letters. Well, we've only saved what? A. So I want the determinant of A. If you want to close the parenthesis, you can, but you don't have to. And then press enter. And it's telling the determinant of matrix A is over here, 7. So what does this tell you? We can solve a system using Kramer's, right? Using Desmos. So that's great that we're able to get determinants there. Let's go ahead and do a system. Actually, let me show you the rest. Let me show you now how to multiply matrices. So let's say, new matrix. Now let's say I want to change the letter of this matrix. Oh, hold on, let's go back. Let's say if I go new matrix, it's just going to go in alphabetical order. Let's say I want to choose G because I like G. What you would do is you click G and then press matrix, and now it's assigning letter G to a matrix. If you don't do that, it will just go in alphabetical order all the way down. Let's do matrix G. Let's make this a 2 by 3. And let's enter in the numbers -1, 2, -6, and 3, -1, 4. And now how do I save this in Desmos memory? Enter. Perfect. Now let's do another matrix. I'm going to call this matrix B. So I typed B and then I press new matrix. This is going to be a 3 by 2. The first element is -6. 4. Second row will have -2, 3. Next element will be 1, -4 is our last element. And then I want to save this, enter. So now, let's say I want to multiply G and B. I first save them both in Desmos memory. Now, all I have to do is tell Desmos I want to multiply them. Does order matter? Yes. So I want G times B. So we're going to do G, multiplication sign, B, enter. And then if you look all the way over here, this is our product matrix. -4, 26, -12, -7. Isn't that cool? We could do any operation with the matrices. Yes.
Is it like the Desmos section is just like fully the calculator, or are there going to be things that we have to compute by hand and then put it into?
Yes. So when we do a system of equations, it's not fully calculator. There are things you're going to need to write down. So when we're doing a system of equations, which I'm going to show you next, I'm going to show you what I need you to show me before plugging into the calculator. I won't just ask you to multiply two matrices in the calculator section. So it's all going to be linked to systems of equations and word problems. All right, inverse matrix. Let's say I have, let's get a new matrix here. Let's say I have the matrix 1, 2, 3, 4. There's my matrix C. What am I going to do to save it? Enter. Now let's say I want the inverse of matrix C. What we're going to do is we're going to press C. And then do you guys see where it says a to the negative first power? You're going to press that. Now it's saying C to the negative first power. That represents the inverse of matrix C. Press enter and look over to the right. It gives me this. I don't want any answers in decimals on the test. I will not accept any decimal answers. So do you guys see how right next to it, it shows the little fraction bar? If you click that, it immediately changes it to fractions for us, which is how I want all the answers on the test to be, as fractions. Am I going too fast? I feel like it's pretty self-explanatory. Yes? All right, let's do a system now. Let's do a system of equations. So we're going to solve this system two different ways. We're going to solve using Kramer's Desmos, and we're going to do matrices Desmos. So the first one, we'll solve using Kramer's. Okay, if we're going to solve using Kramer's, is this a good setup? No. Remember, we want it in the elimination setup. We want variables on one side, constants on the other side. So my first equation, I'm changing 2x plus 3y plus 4z equals 4. All I did was add the 4z over. 5x plus 7y plus 8z equals 9 is perfect. And then the last one, all I have to do is move the 7 over. 3x minus 2y minus 6z equals 7. So now I need all my different matrices that I'm going to need to find determinants of. Who remembers what my first matrix is going to be? Good, the coefficient matrix. So I have 2, 3, 4, 5, 7, 8, 3, -2, -6. My matrix B, which we used to call this used to be D. This used to be D sub X. Remember that? So do D and then D sub X. All right, I'm calling this matrix B because there is no D sub X, right, in Desmos. So I'm going to call this one matrix B, but we'll think of it as our D sub X. Who remembers what did we do for the D sub X? All right. Good. We're going to keep the same matrix as A, but now I'm going to replace the X column with the constants. So my first column is 4, 9, 7. My other two columns stay the same. And then I'm going to go on to matrix C, which I'm going to put in parentheses. This is what we used to call D sub Y. And this time, I'm going to replace the Y column with the constants. So 2, 5, 3. Now I'm going to replace the middle column with 4, 9, 7. And then 4, 8, -6 stays the same. How many more matrices do I need to make? Just one. So I'm going to call this matrix D, which we used to call D sub Z. And I'm going to replace the third column. So 2, 5, 3 stays, 3, 7, -2 stays. But now the 4, 8, -6 gets placed with 4, 9, 7. So if this was a test question in the Desmos part, you would still need to show me all of this. You would need to show me that you're putting all the equations in the elimination format. You would need to show me all of the matrices that we're going to be using. The last thing you'd have to prep to show me is what each one represents. So we're going to say X is equal to the determinant of matrix B divided by what? The determinant of matrix A. You're going to need to show me that Y is equal to the determinant of matrix C divided by what? The determinant of matrix A. And you'll have to show me that Z is going to be the determinant of matrix D divided by the determinant of matrix A. Is it important that I have those straight lines? Yeah, what do those straight lines mean? The determinant. So if you just wrote B over A, that means you're saying divide matrix B by matrix A. We, first of all, don't divide matrices. Second of all, that's not how we use Kramer's. All right, so this would be all the prep work. The next thing would be just going to Desmos and plugging this in. Yes.
When you say you have to show like the X, Y, and Z were equal to, do you mean like the literal, like find the determinants and then
No, I need you to show me this right now. Just how I wrote it out. Now we're going to go and plug them in and do that. So exactly what I've written is what you would need to write. So now we go to Desmos and let's clear everything. See where it says clear all? It clears all previous memory. So now we're going to start with our first matrix. What did we call our first matrix? A. So I'm going to call A, new matrix. And this was a 3 by 3. So I have to increase that. And now I'm going to enter in all the elements for this 3 by 3. So I entered in my matrix A. I'm going to save that. What should I enter in now? Matrix B. So say B, new matrix. Again, it's a 3 by 3. And then I'll press enter. And now to solve for X, I'm only going to do x because then we get the gist of this, right? To solve for x, what I'm going to do is I'm going to do the determinant of which matrix? B. So I'm going to press determinant and then I'm going to press B. I'm going to have to close my parentheses and then I'm going to use my division sign. And then I'm going to press determinant of matrix A and close my parentheses one more time. And then we press enter. And what do we get for x? 3. How much easier was that instead of doing the minor or diagonal method? So x would equal 3. If you kept doing this, you'd get y is equal to -2 and z is equal to 1. All right, now I'm going to show you how to do the same problem using matrices. Are we ready? So same system, but now solve using matrices. So if we're going to solve using matrices, A is going to be our coefficient matrix. Which we already did this. This was 2, 3, 4, 5, 7, 8, 3, -2, -6. B is going to be our variable matrix. And C is going to be our constant matrix. Yes. Oh, sorry. Thank you so much. X, Y, and Z. And then our constants are 4, 9, 7. So if we're solving using matrices, and it's the Desmos portion, I need you to write all of this out. I need you to write out what your A is, your B is, what your C is. Of course, if the equations needed manipulation, you would have had to manipulate them. Yes, Stephen?
You have to say like coefficient.
No, I'm just telling you that. You don't have to write that. The next thing you would have to show me is that B is equal to the inverse of A times C. That is it. If we're solving using matrices, this is all you would need to prep work show me. Now we just go into Desmos and type this all in. So I'm going to go to Desmos. And we already have our coefficient matrix. Isn't that matrix A? So now I'm going to just find the inverse of matrix A. So I'm going to say A inverse. And what am I going to multiply? Oh, wait, I can't do this yet. What should I do? First, enter in matrix C. So let's do that. Do we have a matrix C up here yet? No. Okay. So I'm going to enter in my new matrix C, which was a 3 by 1. And that's 4, 9, 7. Enter. Okay. Now I have my A and my C. So now I'm going to do the inverse of A times C. Enter. And what does it give us? 3, -2. Isn't that the answers I told you? That using determinants. All right. Wait, Desmos wait or wait question? We're okay?
Yeah.
Too fast? All right, that is it, guys. And because let me stop recording.